says, so we're doing solving. We're doing first degree solving trig right now. So it's just sine theta. So that would be to sine 1 theta, right? Not sine squared theta. Change when you have degree 2's. So the very first thing we want to do when we want to solve algebraically is we actually want to get the sine or the cos or the tan when it's a degree 1 function, which this one is, by itself. Very first step. Okay? Because you have to get it by itself in order to get the reference angle. So we're going to divide both sides by 2. And you did do this last year. So we're going to get sine theta equals 1/2. So step 1 is to get it by itself. Did that, right? Then we have to get it by itself and we get the reference angle. The reference angle is always the positive version of this. So you guys know that in the first quadrant of a Cartesian plane, in the first quadrant, the reference angle is the quadrantal angle, right? The very first angle in quadrant 1 is also the reference angle. We agree with that statement? So if we always find theta of the positive here answer, we'll always get the very first angle, which is also our reference angle. And our reference angle is helpful to us, okay? So if this was negative 1/2, I'd still be finding sine inverse of positive 1/2. You always find theta of the positive. Okay, that's how you get your reference angle. So find the reference angle on your calculator by using the inverse of whatever trig function you're given. Always put in the positive trig ratio. So this is my trig ratio, 1/2. I need to put in the positive. It happens to be positive, so that's great. So I'm going to go theta. If I'm trying to find theta, I have to do sine inverse, right? That's how I get the sine inverse to move over here. So sine -1 of 1/2. And you know what? You sine inverse, cos inverse, tan inverse whenever you're trying to find an angle. You always find the inverse of the trig ratio when you're finding an angle. And you don't use the inverse, you use just sine, cos, and tan when you're finding an answer. Okay? So if you're finding an angle, you're going to inverse sine, inverse cos, inverse tan. And that's what we're trying to find. We're trying to find the reference angle. Okay? Now, sorry. Most people will find it in degrees always because they find degrees easier. They get their answers in degrees and just convert their answer at the end to radians. That's what most people do. I'm completely fine with that if that's the way you want to go. So if you want to find your answer in degrees, which first off, this one is in degrees, so I want to find in degrees anyways, what mode do you need to be in? Because I'm going to press second sine. And the moment I hit that sine button, I have to think, what mode do I need to be in? Degrees. So go to degree. Make sure your calculator is in degree mode. Do I have to like zoom trig it now or anything? No, I haven't put anything into y1, y2 of this question, right? Okay. So I'm going to go second sine of 1/2. What do you get? So go second sine 1 divided by 2 in your calculator. You get 30. 30 is the reference angle, right? It might also be an answer to this, but it's the reference angle for sure. So we're going to do, so I always do reference theta. So reference theta equals 30 degrees. We agree? So that's our first step, get our reference angle. The second step is to draw where the heck that exists, okay? Often you're going to have at least 2 answers because sine theta equals 1/2 is in 2 spots on the Cartesian plane between 0 and 360, because it's off the unit circle, actually, 1/2. So where is sine positive? Because we're looking for sine positive 1/2. 1 and 2. Now all we have to do is use our reference angles and we get our answers. It's 30 to here. So what's the angle on this arm? 30. Because the reference angle is the exact same. And then it's 30 to here. So how much is it to actually get to this arm? 150. Have my 2 answers. I'm done. This particular answer I could check 2 ways. Go to my unit circle, look where sine is positive 1/2. Where is y positive 1/2? 3150. Done. So this one I wouldn't even have to do algebraically because it's a question, it's an answer off my unit circle. I could also check with my calculator. So what are you going to do? You're going to go to y1. Now, I told you you can type this in any format you want. You could type it in right away off the beginning. 2 sine theta is y1 and 1 is y2. You could do that and it will find them. because you're only just taking the x values, right? Or you could go y1 is sine theta and y2 is a half, and it'll get you the same answers. It doesn't matter which of the two versions you put in. You can put in the original, y1, y2. You can put in this one, y1, y2. You'll get the same answers. So this half of the class, I want you to put in the original. So I want you to do y1 is 2 sine theta, and y2 is as 1. So the original question. This side of the class, I want you to put y1 as sine theta and y2 as a half. What mode do we need to be in? Degrees. We already in it because we found that. Then we can go zoom trig, and it'll set our window up at least to some sort of a trig window, right? What do I want to restrict my domain to? 0 and 360, because I only want to see what this question is asking me to find. So my x-min will be 0, my x-max will be 360. How many times does it cross? Doesn't matter what side of the room you're on. How many times does it cross? Twice. Okay? So do second trace 5 of the very first crossing. Every single person in this class is doing that right now. Very first crossing. Second trace 5, enter, enter, enter. We agree? Now everyone on this side of the classroom, find someone on that side of the classroom and show them your calculator. It's the exact same answer. Your graphs look different. Go. Move. Disperse. And for someone from this side has to go to this side. There's more people on this side than this side. Go. Show them your calculators are different. Your answers are the same. Now, you guys, why does the y value not matter? We're based on the solution. We want the x value. The y values on this side of the class, for both points, the y value is going to be 1. Because it was equal to 1. The y value on this side of the class is going to be a half or 0.5 because that was your horizontal line. So the y value doesn't matter. Only the x does. Does that make sense? We could have actually done it a different way too. We could have moved the entire thing over. We could have made y1 be 2 sine theta minus 1 and y2 be 0 and found an answer that way too. You can rearrange the equation all you want. Just whatever's on the left side goes in y1, whatever's on the right side goes in y2. Make sense? So you get 30 and 150. Does that make sense? Okay. If I say solve algebraically and you use your calculator, is that any form of algebraically? People will fight me. They'll be like, I moved the equation around. That's algebraically. No. The moment you typed it into your calculator, that is a calculator. That is graphically. Stop the madness. Okay. 2. Let's solve this one. So it's between 0 and 2 pi. But if you guys want to do it in degrees first and convert, that's absolutely fine. Okay? Absolutely fine. Also, if they wanted the exact values of radians, it's really hard unless the radian is exact. It's hard to do it in, because they'll give you a decimal, right? When you do like second cos of something, it'll give you the decimal, and they want exact values. It doesn't work. So a lot of the time, it's actually better in some ways, especially if it's exact values, to do it in degrees, convert to radians. And based on my past experience of how many years, you will just do that. There's like one person who likes radians, and the rest will just be like, I like my degrees. I'm just going to stick with those. I'm going to convert at the end. We're going to be good. Okay? So the very first thing I need to do, find a reference angle. We agree? Okay. So how do we do the reference angle? Well, we have cos theta equals negative 0.8090. Well, that's negative. That's not going to get me the angle in the first quadrant, is it? No, because it's negative. So to find the reference angle, I always do positive. So reference theta equals cos neg 1 of 0.8090. Now, the catch is that's not actually an answer to the solution because I'm finding where cos is negative, right? But it'll give me a reference angle. So when you type that in, what reference angle do you get? What mode are we in right now, most of us? Degrees, probably. You can be in radians, but you're going to get a crazy decimal. Get exact values will be hard. So what does that give you for a degree? 36? Does everyone get that? So 36 degrees. That's lovely. That's my reference angle. How do I find out where the heck my arms are? where cos is negative. I have to use cast. And why is it where cos is negative? Because cos is negative. So we do our cast, C-A-S-T. Where is cos negative? 2 and 3. And it has a 36-degree reference angle, so I'm going to kind of draw it appropriately. There's 36 here and 36 here. So the angle is always from 0 to that arm, correct? So we're always starting at 0 to that arm. So 0 to this arm is how many degrees? 180 minus 36. So 1. What about this one? From here to 36. It's going to be 180 plus 36, which is? So these are wonderful answers. They are correct in degree. But my domain is restricted to radians. So what's my last step have to be when it's like that? Convert, convert, convert. So we're going to do, nope, 36 is not one of the answers. That would be done. So we're going to do 144 times pi over 180. And what does that reduce to? 4 pi over 5. And then we're going to do 216 times pi over 180. What does that reduce to? 6 pi over 5. Those are my two answers. I'm going to check them in my calculator. Now, I can check these in my calculator in radian mode. They're going to be in decimals, correct? So the only way I'm going to be able to actually compare them is if I go 4 pi divided by 5 and find out what that is as a decimal. 6 times pi divided by 5, find out what that is as a decimal. And it should be the same decimals you get on your calculator, correct? So we'll try one more with our calculator. So I would go y1 cos theta. I'd go y2 negative 0.8090. So you should do that. y1 is cos theta. y2 is negative 0.8090. What mode are we in? Radian. What's our window in right now? Degrees from the last question. So my mode's in radians. Once I change my mode to radians, I can now go zoom trig, and it'll change my window to radians, right? Now, if you want, you can restrict your window to 0 and 2 pi, correct? So your x min would be 0. Your x max is 2 pi. It'll take your 2 pi that you punch in, and it'll change it to the decimal that 2 pi is, which is absolutely fine. Okay? That is still 2 pi. It just changed it to a decimal. It just won't keep the pi there in the window. And then you do second trace 5, enter, 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 get your one solution. Second trace 5, enter, 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 get your other solution. And they should be these two in decimal form. Okay? So your calculator is a good one for checking. Or if it was a multiple choice, hey, power to you. We have curriculum outcomes that state you have to be able to use your calculator too. You have to be able to solve these algebraically. And what they'll say is, excuse me, if you keep it in this form, y1, y2, you're finding the x values of where they intersect. So that's what they'll do. They'll say, how can you solve the following equations? Or how many of these are true? Now, this would be true if I said y1 is equal to cos theta, y2 is equal to negative 0.8090, and then I find the x values of where they intersect. But what could also be true is if I change this to be cos theta plus 0.8090 equals 0, correct? And I made y1 be this, and y2 be this, and some people will say, well, then it's still the x value of where they intersect. True, but what else could they also say that you're finding if it's equal to 0? The x-intercepts. So in this case, what they might say is y1 is this equation, y2 is 0, calculate the x-intercepts of the graph, because that's what you're also doing. You're finding the x-intercepts, because you're finding where it crosses y equals 0, and what is y equals 0? The x-axis. So you're finding the x-intercepts. Okay? They do whatever they want. They swap them either way. And they'll ask questions straight up like that, how you would do it in your calculator. Okay? So for 3, we have a reciprocal function, so it's a little different than the previous one. What I want, and it's restricted between 0 and 180. So, same steps. Get the trig ratio by itself. I'm going to divide the 4. Cotan theta equals 1/4. Okay? Now I can go cotan -1, right? But is there a button in your calculator that is that? No. Okay. You guys told me yesterday when we were going through the unit circle and the day before, if you were looking for cosecant, you just went to the answer and you did what with it? You went to the sign answer and you did what with it? You flipped it. You had the reciprocal, correct? And then you would have cosecant. So we're just doing this backwards. They gave me cotan of 1/4. So that's the same as tan theta of what? 4. You can flip your answers. You can never flip your angles. I'll get people to see doing this. They do cotan of 60 degrees. Then they tell me, oh, that's tan of 1/60. This is so not good. This is so just bad. It's just like, that is bad. That's like a math ticket. If I was a math police. Like that is like that's so bad. That's like running a red light. Okay? You cannot flip the angle. This is actually the same as 1/tan of 60. And the reason why it's so bad is they actually tell you it on your unit circle. Cotan theta is 1/tan theta. Like I'm a unit circle. Why do I keep calling this the unit circle? Formula sheet. It says exactly here what to do. So you don't flip your angle. You would actually put it 1 over it. But you do flip your answer. Does that make sense? You flip your answer. You do not flip your angle. Okay? So this is the same as tan theta of 4/1. But I'm just going to write 4 because I'm lazy. You don't have to write it over 1. But you can. And now we can just do the same work we did before. We want to get a reference angle. So we take tan inverse of the angle. So we're going to do theta, or reference theta, equals tan -1 of +4. It just happens to be a +4, so that's great. If it was a -4, we'd still do +4. I would have my calculator in degree mode if it were me, because I would want my reference angle in degrees, plus it's in degrees, the restricted domain. So where does tan -1 of 4 exist? 75.96. I'm going to say 75 point, what was it, 96 what? So I'll say 96 degrees. So that is my reference angle. How do I figure out where the heck that occurs? It's where tan is positive. Where is tan positive? 1 and 3, but the bottom ones are out because the domain's just between 0 and 180. So we could get an answer down here, but it's outside of my domain. So this is how they could do it so that they get a numeric response with one answer, right? So what's my answer just? Once again, you could put in your calculator and check. We're not going to do that right now. Calculator isn't as bad now once you've done the calculator a few times, right? It's just overwhelming at first. Okay. So this is actually my answer. Next page. What happens when there's a squared? You square root, but we're going to have to do something else first. Divide by 4 first. So we have cosecant squared theta equals 25/4. Then we square root, and this is what everyone forgets. And if you're someone who would have forgot this, when you square root, what do you have to remember to do? Plus or minus. If you don't do plus or minus, you are not going to get angles in the negative quadrants, and you will get 2 instead of 4 answers. Okay? If you're that person who would forget that, you leave yourself a little note. So cosecant theta equals plus or minus root 25/4, which is cosecant theta equals plus or minus 5 over 2, right? Now, to get the reference angle, I do not care what the negative is. To get the reference angle, I always take the positive, right? So I'm going to, but what's my issue? I have an issue first. It has to be sine. What happens when it's sine? So this is sine theta equals plus or minus 2 over 5. Now, do I really care about the cosecant anymore? No. Sine and cosecant are positive and negative in the same spots, right? So we're okay to switch to sine and go with that. So now we're going to do reference angle. Reference theta equals sine neg 1 of 2 over 5. The domain is in radians. I don't care. I'm going to do it in degrees because that's what you're going to do it in. I quit fighting the radian thing. So what do you get for a degree? Sorry, what was it? 23.578. So I'll go 5.8 degrees. Really? Really, if you're switching this to radians, you should probably keep a few decimal places more than that when you convert, so you don't round too early and then you round with radians, then you make a mess. Okay? You can also check with your calculator. Now, if I use cast, where is sine positive and negative? Every quadrant. Because I need positive and negative. Do you see where's the problem if you forget to put the plus or minus sign in front of the square root sign? You're going to get half the answers. People do that. They will have half the answers on the diploma as one of the answers because that's common error 101 on these questions. Is forgetting the plus or minus sign. And now you just fill in your reference angles. So this one's going to be 23.5, what is it, 76, something? I don't remember. 578. Okay, and then this one's going to be 180 minus that. And this would be 180 plus it. You really need to have a degree symbol on all of these. And then this would be 360 minus it. Done. No. You need to put it in radians because what's my domain restricted into? Radians. And honestly, because these are decimals, your radian measure will never be exact. Right? We're rounding. So you're going to have to go that degree times pi divided by 180 and give me a decimal. Because this degree doesn't terminate. So I can't make an exact value radian out of it. Okay? So you'll have to take that decimal, times it by pi, divide by 180. And you're going to get, for this one, for the first one, it's 0.41 radians, and then 156.422. If I went to go put that in my calculator, how the heck do I put in cos squared theta? Do you remember cosecant? Cosecant is 1 over sine. We agree? What do we do with the squared? What did I tell you to do? All in brackets, squared, right? So if I went to put this in, my y1 would actually be 4 bracket 1 divided by sine theta squared. And my y2 would be 25. Now some people will say, well, I can't find my y2. My window's at 4. If your y max is at 4, you have a horizontal line above your calculator floating in space, nicely at 25. So you're going to have to change your y max to that. right? So your y max and y min, if you have just a number like 25 or 10, or it has to be there, right? Or you're not going to see it. You're right. Can I see your textbook? So make sure you do those quiz ones. You'll have some time at the beginning of class to do them as well, algebraically, the 4, 5, and 6. But we're going to be doing more solving tomorrow too, because we have to do second degree ones too, like where it's like sine squared theta plus sine theta minus 1 equals 0, and you have to factor them. It's probably in degree mode. Oh, it's really just wants to quit. Okay. So for today, there's just going to be a few. Page 202. Yeah, so number 10, 11, and 12. Now, I want you to look up here for 1 second, please, because this is where it's going to confuse people. This is stuff you didn't do last year. So say for this question, instead of it being between 0 and 2, I'll go to one that's not as awful. Let's go to the previous one. So for this question up here, instead of being between 0 and 180, let's pretend that they had restricted the domain to be between negative 180 and 180. Okay? Do these exactly the same. Get your same answers between 0 and 360 like you normally would. Okay? Then just get the coterminal negatives. Subtract 360 from whatever your 0 to 360 was. Subtract 720, whatever you need to do. And then keep the ones that fall between here. Okay? So my answers between 0 and 360 in this case would have been here and here. So 75.96 degrees, which falls in there. Yay. The other one would have been 255.96 degrees, which does not fall in there. But if I take 255.96 and I subtract 360 from it, I get negative 104.04. Does that coterminal angle of that fit in it? Yeah. So do I have to do anything fancy or different? No. You just get your normal answers between 0 and 360 and then find their coterminals. And if their coterminals fit in this, yay. If their coterminals don't, meh, done. So for this answer, if this was actually the restricted domain, my answer would be 75.96 degrees and negative 104.04 degrees. And how the heck did I get that? I just took this angle and subtracted 360 from it. Because if I subtract 360, it's just going to give me the same arm, is it not? So you still always, no matter what the domain is, you still always find between 0 and 360, and then just subtract 360 off of them and see if they fit in the domain, or add 360, because the domain could be bigger. It could be from 0 to 4 pi then or something, right? So you're just finding coterminals. The quickest way. Some people try and like draw them out and visualize. That is, I used to do that. That was never a good method. I had so many people lost. If you just find the angles between 0 and 360 or 0 and 2 pi and then just find their coterminals and see if they fit, this is the best way.